Welcome to Unit 2, where we are going to be solving equations and inequalities. In this lesson, we want to concentrate on solving equations with multi-steps, solving equations with like terms, and solving equations with the distributive property. As a reminder, if we want to solve an equation, our job is to figure out the value of x. What number can I plug in and multiply by 6 and add 4 and get 7? To figure this puzzle out, we are going to use inverse operations to help us isolate x or get it by itself. When solving equations, we want to follow the following 6 steps for every problem. Step 1, we want to distribute. After we distribute, we want to eliminate any fractions or decimals that may remain. Next, we're going to combine any like terms. After that, we are going to add or subtract. Then we are going to multiply or divide. And finally, we're going to check our answer to make sure the solution actually works in the equation. For our first problem, 6x plus 4 equals 7, I like to draw a line through my equal sign to differentiate the left-hand side of the equation from the right-hand side of the equation. Step number 1 asks us to distribute. There is nothing to distribute for this problem. Step number 2 asks us to eliminate fractions or decimals. There are no fractions or decimals here. Step number 3 asks us to combine like terms. On the left-hand side of the equal sign, 6x and 4 are not like terms, so they cannot be combined. On the right-hand side of the equal sign, we simply have the number 7. No like terms there. Our next step is to move anything over from one side to the other that would be moved using addition or subtraction. In order to get this x by itself, I'm going to have to remove both the 6 and the 4. Since 4 is being added, we would need to move that over using the inverse operation of subtraction. 4 and negative 4 are additive inverses and are going to cancel out. So we are left with 6x equals, and then 7 minus 4 is 3. Our next step in the process is to move anything over that involves multiplication or division. I can see that 6 is multiplying the x. So I'm going to undo that by getting rid of the 6. I'm going to use division. The 6 multiplying the x and the 6 dividing the x are multiplicative inverses and cancel each other out. So we find that x is equal to 3 over 6. Anytime we have a fraction, we want to make sure that we simplify that completely. 3 over 6 can be reduced to 1/2. Therefore, we believe that since x is by itself, we have isolated the variable, its value will be equal to 1/2. Our very last step in the process of solving is to check this answer and make sure that it is correct. We check by plugging this value into our original equation in place of x. This becomes 6 times, and then in place of x, I'm going to put in a 1/2. Remember, when I substitute a number in, it's important to put parentheses around it. Then I see a plus 4 should be equal to 7. Order of operations says we want to multiply these two things before we add that. So 6 times 1/2 is 3. And 3 plus 4 is 7. Since we got a true statement here that 7 is in fact equal to 7, we are confident that x equals 1/2 is our solution to the first question. Problem number 2. I like to draw my line to separate the left-hand side from the right-hand side. There is nothing to distribute. There are no fractions or decimals to eliminate. In this problem, there are no like terms to combine. So we are going to start with adding and subtracting. My job is to get x by itself. So to do that, I am going to move the positive 2 from the left-hand side to the right-hand side. I'm going to do that by subtracting because the inverse operation for addition is subtraction. These two cancel and I'm left with negative x is equal to 3. The next step says to multiply or divide. There's an understood negative 1 in front of the x. This reads that negative 1 times x is equal to 3. We are going to undo that multiplication with division, and the negative 1's cancel out. So x is equal to 3 over -1, which is -3. Our final step in the process is to check this answer. Plugging -3 back into the original equation, I have a negative sign. Then in place of the x, I'm going to plug in a -3. Plus 2 should equal 5. Here, -3 becomes +3. I can think of that as -1 times -3 makes +3. Plus 2 should equal 5. And when we check, 3 and 2 does equal 5. And so we are confident that x equals -3 is the solution to this equation. On the last problem, some of you may look at that and it may bother you that the x is on the right-hand side of the equal sign. Remember, the symmetric property allows me to flip this equation over and rewrite this as 2x minus 3 is equal to -11. It is not a requirement to do that, but some of you may prefer to do that. There is nothing to distribute here. There are no fractions or decimals to eliminate, and there are no like terms to combine. So we are going to start by moving things over that involve addition or subtraction. That -3 needs to be added, and those cancel. So 2x is currently equal to -8. Our next step in the process is to multiply or divide. So we will divide both sides by that 2 that is multiplying the x, and we find that x should be equal to -4. Our last step here is to check. I'm going to take -4 and plug it in to my original problem. So -11 should equal 2 times -4 minus 3. Again, remember those parentheses. Cleaning up the right-hand side, 2 times -4 is -8, and -8 minus 3 is in fact -11. And so I am confident in my answer of -4. The next type of problem we want to solve are equations that involve like terms. It is important for us to understand what like terms are. Like terms are terms that have the exact same variables with corresponding variables raised to the same power. Notice that the definition involves two things: variables and powers. One example of something that are terms that are like terms are 7x and 9x. They meet the definition. We have the same variable here. Both terms contain the variable x, and the power on those variables are the same. This x is understood to be the first power, and this x is understood to be to the first power. Notice the definition does not address the coefficients or the numbers in front of x. They do not have to match. What has to match from term to term is the variable and its exponent. A second example of like terms are 2x squared and -6x squared. We can see there that both terms contain the variable x, and both of those x's are raised to the second power. A final example is 4xy cubed and 9y cubed x. Again, both terms contain the variables x and y, and those variables that are corresponding have the same power. This x is to the first power. This x is also to the first power. This y is to the third power. This y is also to the third power. Therefore, we have like terms. Notice the variables are not in the same order. That's okay. The definition doesn't address the order of the variables. It just says that the terms have to have the same variables and that those variables that are alike need to have the same power. Let's look at some non-examples. -20 MP and -40 MP squared are not like terms. While these two terms contain the same variables, those that are corresponding are not raised to the same power. We see that this p is raised to the first power, while that one is being squared. A second example of something that is not like terms is 7m and 2n. We can see in that case, these two do not have the same variables. A final example is 2m squared p cubed and negative 3m cubed p squared. While they do contain the same variables, both of these terms have an m and a p, we can see that they are not raised to the same power. This m is squared, while that m is cubed. Likewise, this p is cubed, while that p is squared. So we have an issue with our exponents there. Let's try solving with like terms now. Again, draw a line at your equal sign to separate the left and the right-hand side. Moving through our steps, there is nothing to distribute here. There are no fractions or decimals to eliminate. The next step we come to is like terms. We should see that 3x and negative x are like terms. They both contain the variable x, and that variable is raised to the power of 1. We want to combine these. 3x minus 1x gives us 2x plus 8 equals 90. Now we have a problem like we were working before. We're now going to move on to addition or subtraction. 2x is added to 8, so we're going to subtract 8 on both sides. Those cancel, so 2x is now equal to 82. Moving on to multiplication and division, we will divide both sides by that 2 and find that x is equal to 41. Our last step is to double check that that answer is correct. Everywhere we see an x, we are going to plug in a 41. So here and again there. So 3 times 41 plus 8 minus the value of x is 41 should come out to be 90. 3 times 41 gives us 123. And then we'll add and subtract from left to right. 123 plus 8 gives us 131. And 131 minus 41 is in fact 90. And we check. A second example involving like terms. Draw your line. Step 1 asks us to complete the distributive property. There is nothing to distribute on either side. Step 2 says remove fractions or decimals. We have no fractions or decimals. Step 3 asks us to combine like terms. We should see that we have like terms here with 3y and negative 5y, and we also have like terms over here with negative 6 and positive 4. Combining our like terms, 3y minus 5y gives me negative 2y. And on the right-hand side, negative 6 and positive 4 make negative 2. The next step asks us to add and subtract. We're going to move anything from one side of the equation to the other that involves addition or subtraction. This is a plus 3, so to move it, we're going to subtract 3. Those two are going to cancel out, and negative 2y is going to equal negative 5. Dividing both sides by negative 2, we find that y is equal to negative 5 over negative 2, which actually reduces to positive 5/2. You should check your answer by plugging 5/2 in for both of the values of y. The final solving we want to do is to solve equations that involve the distributive property. Step 1 says distribute. We are going to distribute this 3 to both the x and the negative 2. 3 times x gives us 3x, and 3 times negative 2 makes negative 6. Be very careful with distributing that you are conscious of your signs. Drawing my line down the equal sign, the next step says to remove any fractions or decimals. In this problem, we don't have any fractions or decimals. Our next step asks us to combine like terms. There are no like terms. We will now move anything that needs to be moved that involves addition or subtraction. This -6 will need to be added to move it to the other side. These cancel, and 3x is equal to 13. Dividing both sides by 3, we find that x is equal to 13/3. Our next step is to check. We are going to take a 13/3 and we are going to plug it into our equation everywhere we see an x. This is now going to be written as 3 times, and in place of x we're going to put in the fraction 13/3 minus 2. And what we want to know is if we get 7. You are welcome to use any sort of calculator to help you with this check. 3 times the fraction 13/3 and then we want to subtract 2 and close off that large parentheses. Notice that it says that that is equal to 7. That's what we wanted. 7 is equal to 7, and we check. Our next example. First step is to distribute. -7 is going to be distributed to both the x and the -3. The first part here is pretty simple. -7 times x makes -7x. This is where students often make a mistake though. -7 is now going to be distributed to a minus or a -3. Students often miss these signs. -7 times -3 will make a positive 21. Be careful there. All right, drawing our line. Our next step says that we should eliminate any fractions or decimals, which we don't have. Next, we are combining like terms. There are no like terms here on the left or the right, so we move on to addition or subtraction. We will subtract 21 from both sides and get that -7x is equal to -25. After addition and subtraction comes multiplication and division. Dividing both sides by -7, we find that x is equal to -25 over -7. Remember, a negative divided by a negative becomes a positive. And so to completely simplify our answer, we would have positive 25 over 7. We want to pull out our calculator and now check this. We would have -7 times the fraction 25/7 minus 3 should equal -4. On our final two problems, again, we want to distribute. Notice that there is a fraction on this problem. Please distribute first before you attempt to eliminate the fraction. You may not have a fraction anymore once you distribute. 1/2 gets distributed to 2x. Half of 2x is 1x. 1/2 is also going to get distributed to 10. Half of 10 is 5. Continue to write the remainder of your problem. Notice that when I distributed, that fraction went away. There are no fractions or decimals in our problem to eliminate, and so the next step we come to is to combine like terms. We should see that we have two sets of like terms here. X and -2x are like terms, and likewise positive 5 and positive 2 are like terms. Let's combine them. X minus 2x leaves us with -x. And positive 5 and positive 2 make 7. After we combine like terms, we want to add or subtract. We need to move the 7 over by subtraction. And then understand that there is a -1 in front of this x. So we need to get rid of that -1 by dividing, because it is -1 times x. The inverse operation there would be division. The -1's cancel, and we find that x is equal to -2. Please take time to check your work. In our final example, we also need to distribute. we need to make sure that we are distributing what is directly in front of this parenthesis, which in this case is a minus sign. We will hold the 4 and distribute that negative to both the x and the 2. Negative times x makes negative x. Negative times 2 makes negative 2. Our next step is to eliminate any fractions or decimals. We don't have any of those, so we move on to like terms. At this point, we want to combine like terms. 4, negative 2, and positive 7 are all like terms that need to be combined. 4 take away 2 is 2. 2 plus 7 gives us 9. This now says 9 minus x is equal to 6. Next, we move over anything that needs to be moved by addition or subtraction. This 9 needs to come over here with the 6. Since as I understood positive 9, we are going to subtract on both sides. The positive and negative 9 are additive inverses and cancel, so negative x is equal to 6 minus 9, which is negative 3. Remember, there's an understood 1 in front of that x. Negative 1 times x means that we would need to get rid of that negative 1 by dividing. These cancel, and x is equal to negative 3 over negative 1, which is positive 3. Again, be sure you check your work.